Hi, everyone. I'm Babak Poushanchi, founder and managing partner at Cota Capital. We have a great Cota Access one-on-one event for everyone lined up today regarding the rising role of artificial intelligence. We are clearly at a major inflection point in the innovation cycle and the technology cycle. And I think there's a lot of intrigue out there with the rapid rise of ChatGPT to understand better both where AI came from, what the current status is, and what the prospects and the potential implications of this rapid rise are going to be. With me today is Rich Ellinger, who's partner and chief technology officer at Cota Capital. Rich is an engineer, a serial entrepreneur, multiple successful exits, including an IPO over the last 30 plus years, started his career at Oracle as a software engineer, and graduated from Stanford with a degree in computer science. And he will provide a presentation that will cover sort of, is AI the next hype cycle? Is it real? Is it not real? Is there a difference between AI and generative AI? What are sort of the strengths and limitations of the various models? There is an ongoing debate out in the marketplace around whether there's sort of one model or two models to rule them all, or whether we will go down a different road of many models and many custom models. We will discuss areas and sectors that will benefit and some that will face some challenges with this rise in AI. And then when will this all become a reality inside the enterprise? And maybe along the way, Rich, you can answer the question of whether we all on this webcast will still have a job in 5 years or not. I think that's also top of mind for a lot of folks. With that, why don't we go ahead and kick it off to leave plenty of time for Q&A at the end, and I'll join back for that session. Thanks, Rich.
Great. Thanks, Babak. So before we dive into the meat of things, let's just spend a minute, I guess, sort of on the history of AI. So well, I think most people realize AI is not new. I think it's been around a lot longer than people realize. It's basically been around for more than 75 years. And, it's been more than 30 years since, for those of us like myself that may be older in the audience, that Deep Blue beat Garry Kasparov, the Russian chess champion. And it was more than a decade since Watson beat a handful of Jeopardy champions. And along the way, we've also gone through a couple of hype cycles already around AI. The first, we had sort of an AI winter in the mid-70s, and then we had another one sort of from the mid-80s to the mid-90s. And, each of those were sort of characterized by the same set of things. We had a large amount of funding and a large amount of excitement around a single project, in those days, primarily funded by DARPA. The projects didn't go so well, didn't meet expectations, funding dried up, and ultimately research shut down. And, sort of raises, the obvious question in people's minds, are we now sort of at the peak of a third hype cycle or not? And if not, why not? And, as Babak mentioned, we do believe this time's different. And I think there are sort of four, foundational reasons we believe this. The first is that, everything these days is generating data, whether it's your phone, your watch, your car. We're generating a tremendous amount of data. In fact, the quantity of data is roughly, that we collect every year, is roughly doubling every 3 years at this point. And then we pair that with the fact that compute costs and storage costs are getting dramatically cheaper. Compute in particular, which is very important for AI, the amount of compute we get per dollar spent is roughly doubling at this point every 2 years. And when we put those two things together, it creates effectively an architectural unlock for deep learning. So neural networks are, again, not tremendously new, but previously we weren't able to solve complex problems with them because they required a lot of data and a lot of compute. The other architectural unlock that's happened more recently is something called transformers back in 2017. And that's one of the sort of foundational pieces of Gen AI. And we'll touch on that in a little more depth a little later in the presentation. And the last piece is, I think ChatGPT has just made it real for everyone. It's the fastest adopted application in history, and it's really not even close. So it got to 100 million users in less than 2 months. And for comparison, TikTok, which was the next closest app, took roughly 4.5 times to get to that point in terms of time. But in addition to those four reasons, I also think part of what's excited people about Gen AI is, in addition to its ability to sort of produce things, is, while we've had speech recognition technology for a long time, I think this has sort of created the first instance where people feel like we can actually interact with the computer in a conversational way, and as if we were speaking to another human being. And I think that has the potential to unlock a tremendous amount of productivity for folks. So now that we've talked a little bit about maybe the why now, let's sort of get into the weeds a little bit on technology and talk about the landscape of AI and the different types of AI and how they work a little bit and sort of what they're good for. So we started with what are called expert systems now, and these were basically simple rules-based systems that used if-then-else logic to basically encapsulate some amount of knowledge. Then the second category of algorithms it's now called traditional machine learning, and it roughly falls into sort of three buckets: unsupervised, supervised, and reinforcement learning. And then the third type of AI is called deep learning, and it uses an architecture called neural networks. And these neural networks can actually be used to run sort of each of the three types of traditional machine learning. They can run in unsupervised, supervised, or reinforcement mode, if you will. And with that sort of as a backdrop, let's dive into each of these a little more, talk about sort of what they're good for, and a little bit more about how they work under the covers. So the first is unsupervised learning. And what unsupervised learning is good for is problems that involve classification or detection of anomalies. Basically cases where we're asking the computer to say, hey, we don't know the answer in advance, help us figure it out. And so types of problems this is good for are things like customer segmentation or product recommendations, or determining, if there's some anomaly in a machine that might cause it to fail. And in terms of how it works, we're going to use this simple example I've got here on the screen of t-shirt sizing. So you can see my left example is basically, each example is showing sort of heights and weights of people. And what we're showing as a result, where in one case, I've sort of bucketed these people into three categories where I'm going to make them three sizes of t-shirts. And in the other, we're put it in sort of five categories of t-shirts. And the way we got to these results is using something called a k-means algorithm. And so in simple terms, how does that work? So using my left example, in this case, k is how many buckets we want to create. So we created three. And if you imagine, if you will, that each of these circles on the screen basically had a center point to it. And initially we placed these centers randomly on the grid. And we assign basically each person to the closest center point. Then we move those centers around ever so slightly and repeat that process, applying people to the closest center point, until we get to a point where on a given iteration, we basically don't have a person switch which circle they belong to. And while you have to trust me, at the end of the day, you'll end up with a picture that looks something like this. But hopefully that gives you a little intuition for how unsupervised learning works. So next, let's talk about supervised machine learning. So supervised machine learning is good for problems of regression or classification, essentially predicting things. So problems like, does this picture show a person with a heart defect? Or given a set of data on a house, what's this house worth? And to try and give, the basic difference between unsupervised and supervised is that with supervised learning, we actually take a set of known inputs and outputs or answers, and then we use that to train a model that we then use to predict future outputs based on new inputs. And what the little graphic on the screen here is showing us is an example of a linear regression being created. And so let's imagine, if you will, that we use my housing example, and the x-axis was square footage, the y-axis is the number of bedrooms, and then the little dots basically represent the price of actual houses. And what we're seeing here is we have a line that represents the prediction we would make given a set of endpoints, and we're ever so slowly moving that line until ultimately we reach the point where that line best fits the training data and makes the most accurate prediction given the set of data. And that's a basic example of how a supervised learning algorithm might work. The third main bucket is reinforcement learning. And what reinforcement learning is good for is problems where we have a complex environment, there's some unpredictability to it. So things like autonomous vehicles or video games, like the Pac-Man example we're showing here. And in terms of how it works, at a simple level, it starts with we have an agent. So Pac-Man in this case, he's living in an environment. So we've got the monsters and the walls and the little dots he needs to eat. And at any given moment in time, he can take an action. And what we want to do is reward him if he takes a positive action towards his goal, or we want to penalize him if he takes a negative action. And then we basically are in a new state once that happens, and we repeat that process over and over again until we figure out the optimal set of rewards for a given action in a given state that allows him to achieve his goal. And so that's the basic idea of how reinforcement learning works. But, how do we get from these simple examples I just showed you to much more complex things like DeepMind beating the world Go champion, or ChatGPT? And the simple answer to that is deep learning. But what is deep learning, and sort of intuitively, how does it work? And I think the simplest way to understand the difference between traditional machine learning and deep learning is that with traditional machine learning, you actually, if you have a set of inputs, a human being has to figure out which of those are actually the most important or not. And with deep learning, I can just feed it a bunch of raw data and say, machine, you go figure out what is or isn't important. So if I use my housing example to illustrate this, imagine now I have thousands of data points on my house, everything from simple stuff like square footage and lot size to super obscure stuff like, what's the color of the paint in my bedroom walls. With traditional machine learning, an AI engineer, an ML engineer would actually have to go through and essentially manually figure out which of those variables mattered and didn't matter in what combinations. Whereas with deep learning, I just feed it all to the machine, and the neural network is able to, over time, learn and figure out which variables are actually the most relevant and which aren't. So hopefully that gives you a basic idea of how the different types of machine learning work, maybe what they're good for. But before we move on, I just want to spend a minute talking about, some of the limitations of machine learning, because, despite the fact that it seems like you can do somewhat magical stuff, at the end of the day, it is still all basically math under the covers, nothing more, nothing less. So, machine learning today does not actually reason or understand causation. All it's doing is basically inferring associations from data. And the more correlated those associations, the more it's going to presume causation and therefore build those into its predictions. Also, machine learning doesn't know anything about our world other than the data set that it was provided. And finally, because it learns through iteration, oftentimes it's very difficult to reverse solve for sort of how the model reached its output. And that causes some other challenges that we'll talk about in a few minutes. So the next topic I want to talk about is a little bit about the state of the art and sort of what's going on in terms of research in the AI world. And sort of the first area we're going to talk about is transformers. I expect a lot of people have heard about transformers because it's been very topical. They're sort of at the heart of some of the Gen AI stuff. But I think the simple way to think about transformers is it's like they're attempting to give the machine memory. So by better understanding the relationships between different data points, the machine better has context and therefore can better ascribe effectively meaning to things and understanding. And transformers came about roughly in 2017. Google published a paper on this. And originally, transformer architectures were primarily focused on text-based problems. But what we've sort of learned over the last 6 years is that it's actually a great foundational architecture for solving a wide variety of problems. So it's used in a bunch of different contexts at this point. A second area of research is something called diffusion models. And diffusion models are the thing that sit at the heart of some of these newer image generation sites like DALL-E or Midjourney. And again, trying to give people a sort of a simple understanding of maybe how it works is with traditional image generation models, you had sort of a model element that represented potentially multiple pixels. And with a diffusion model, instead, you start at sort of a low resolution, but each model element represents exactly 1 pixel. And then the algorithm makes multiple passes, basically increasing the resolution of the image. But in all cases, you sort of have a one-to-one correspondence between the model element and the pixel, which ultimately results in a more accurate output. The third area of research is something called self-supervised learning. And if you recall, maybe from a few minutes ago, when we talked about supervised learning, the challenge with supervised learning is that it requires a ton of training data to work. So at the end of the day, somehow we have to generate a set of known answers to a set of known questions. And that typically requires a lot of costly human effort. And so the idea behind self-supervised learning is to say, can we have the machine create our training data? And I'm not talking about synthetic data, which is something else, but the idea behind self-supervised learning is, imagine I have, let's say, a paragraph of text, and I remove some words from it, and then I ask the machine to predict what the answers would be. Similarly, I could take an image and remove some pixels from it, and again, ask the machine, tell me what the missing pixel should be. In both those cases, because I started with the full paragraph of text or I started with the full image, I know what the answers were. So voila, I've had the machine effectively create training data for myself. A fourth area of research is called reinforcement learning from human feedback. And I think this is probably the most intuitively named of the bunch. So you may recall reinforcement learning was when we used the Pac-Man example. And the basic idea here is to basically add an extra feedback loop into the process where human beings can fine-tune those rewards that the machine's coming up with to ultimately result in a more optimal outcome. And then the fifth area we're going to quickly touch on is something called multimodal machine learning. And the idea here is, today, typically what we're seeing is something that goes from one modality to another modality, or, there's sort of a one-to-one correspondence. So I go speech to text, or I go, image to text, or text to image. But if you think about how we work as humans, right, we have 5 senses, and we typically process all of those in parallel to ultimately, sort of produce, if you will, an output from ourselves. And the idea behind this area of research is to try and do the same thing with machines, where we're taking multiple modalities simultaneously and attempting to process them. And of course, we couldn't have a conversation about AI without spending a little time on generative AI and large language models. So 3 of the 5 areas we just touched on, transformers, self-supervised learning, and the reinforcement learning from human feedback, are all key components of what basically makes ChatGPT and other generative AI solutions work. Diffusion models are also important, but primarily specifically in the image generation space. And when we talk about large language or generative AI, we're talking about large language models, and particularly foundation models gets a lot of the noise. And obviously OpenAI and Google are 2 of the names that are often talked about. But what this slide's trying to show is, there are a lot more people sort of in this marketplace, and the marketplace building foundation models is becoming increasingly crowded. And that's everything from other FANG players like Amazon and Meta, to well-funded startups like Anthropic and Cohere, to robust open source offerings like Falcon and Bloom and Stability AI. And one consequence of that sort of increasing crowded landscape is it's basically turned into a bit of an arms race, where everybody's sort of trying to create the biggest, baddest model on the planet. And what this slide's showing is one of the results or consequences of that is the amount of compute required to train these models is actually increasing by an order of magnitude every year, which is kind of astounding in the grand scheme of things. And maybe a different way of thinking about it is OpenAI recently produced a report that said they believe by 2030, the cost of training a large language model is going to rise from $100 million to $500 million. And that's despite the fact that the underlying compute costs are going down. And if that proves to be true, then one has to ask the question, do we end up in a world of sort of very few players that can afford to be in the game, and sort of a world of AI haves and have-nots, if you will? And that then leads to something that Babak touched on earlier, which is what I call the great model debate, or for Lord of the Rings fans, will there be one model to rule them all? And on one end of the spectrum, you've got the folks who are building these huge foundational models, spending billions of dollars on it. And I think their argument would be, there's a scarcity of talent. People actually understand the underlying technology. to continue improving is only going to require larger, more complex models that cost more to build. And that ultimately sort of the winning formula, if you will, is this foundation model paired with larger context windows. And for those that aren't familiar with what a context window is, think of it as the prompt and any other information you might feed to a solution like ChatGPT to help it produce a more relevant, accurate answer for you. And the challenge with existing foundation models is those context windows are pretty small, but they are growing. So if we take Anthropic as an example, they just recently released a model that moved their context window size from 9,000 tokens to 100,000 tokens. And to put that in context, GPT-4 currently supports 32,000 tokens. So it is increasing. But then if you look at the other end of the spectrum, the folks that are saying, well, I think the world's going to have smaller customized models, likely based on open source. Many of you may have seen a leaked memo from a Google engineer that basically tried to make the case for this. And I think it was titled something to the effect of, we and OpenAI have no moat. And some of the points he made were, one, that the quality gap between the open source models and the proprietary models is rapidly closing. Second was that actually smaller, nimbler models where we can iterate much more quickly are ultimately going to win over bigger, slower models, particularly with some of the newer techniques like LoRa and COT that have come on the scene. Third, he made the point that in the internet world, open source generally wins over closed source. And fourth, who wouldn't want a free unrestricted model versus a proprietary restricted model? Now, how is this all going to play out? I mean, the jury is clearly still out on this one. But my personal perspective is you're going to continue to see the foundational models push the envelope on what's possible and provide a great on-ramp for people that want to sort of get to market very quickly. But I think you're going to increasingly see more and more people create these smaller custom models that are intent on solving more target or specific problems. And I think that's the way we're going to move. So far, we've spent a lot of time talking about, what AI is, how it works, maybe some of the positives, but I think we'd be remiss if we didn't at least spend a minute talking about and acknowledging some of the challenges and concerns people have, particularly with generative AI. And I would break those, roughly into sort of 5 categories. So the first is bias and discrimination. So as we talked about earlier, models basically are trained on a set of data, and that's what they have access to, and that's what they have knowledge of. So by default, whatever bias and discrimination exists in the set of data they were provided, they're going to exhibit on the output side. So that's sort of one, broad bucket of concern people have, that it reinforces existing biases that are out there. The second is misinformation, or the popular word in vernacular these days is hallucination, and everybody's seen examples of this with ChatGPT. And I think that the big concern here, right, is because the software now writes so eloquently and so authoritatively, that it is, increasingly difficult to tell, fact from fiction. The third area of concern is what we call deception, basically the bad actors, right? Does this technology make it much easier to spread a different form of misinformation, right? So propaganda or deepfakes or what have you. Fourth area of concern is intellectual property, and there are really 2 vectors to this. I think the one most people think about is, it's gotten the popular narrative, is the input data, right? So people using other people's proprietary data as training data, and therefore basically stealing, if you will, their intellectual property. But there's also an interesting legal question out there as to whether if you use the machine to produce outputs, if that is actually protectable, since it was produced by a machine rather than by a human being. And then the last point is privacy and security. And there are many vectors to this challenge, but I think the one that sort of, again, is most popular out there, most talked about, is the issue with people basically putting confidential data into public sources, right? So I put in confidential data into ChatGPT, and it has sort of 2 consequences. One, you've exposed yourself to OpenAI, has now access to that data. But perhaps more troubling is that data that can then be fed back into the model and trained, and that sort of confidential or proprietary data or personal data could ultimately show up in the answer in the future to some random person who asks a question that really shouldn't have access to the data. And I don't want to minimize. These are all real problems. They're all real challenges. I mean, some of them I think are going to get solved through legal means. Some of them are going to get solved through regulatory means. Some of them are going to get solved through continued improvement in the technology. But I guess at the end of the day, I am optimistic that over time we will rise to meet these challenges. But I felt like we should acknowledge them because they do exist. They are real, and they aren't trivial. So the last thing we're going to talk about before we move into Q&A is obviously one of the things we do at Cota is we try and apply our learning to our investment sourcing and diligence process. And one of the things we've been working on internally in our research organization is trying to come up with a framework for saying what segments of the market, particularly the application market, do we think are ripe, if you will, for generative AI. And what this is showing here is a sampling of some of those characteristics, 2 of which are pretty AI specific and 4 of which are less so. So the first is a data factory, and I'm going to talk in a minute a little more about a data factory. But at the end of the day, we fundamentally believe that businesses that generate their own proprietary unique data on an ongoing basis that they can then use to train models and produce unique insights will fundamentally have an advantage over businesses that don't have that. Second, where problems where the productivity is meaningfully enhanced, either because generating content is a big part of the job or extracting and synthesizing key data from existing content, those are problems that are, more applicable for generative AI. Of course, we want to see a valuable end market where there's clear ROI, propensity to spend. We're going to focus on areas where we don't think big tech has a foundational advantage. We're going to look at that competitive landscape, and we're looking for either greenfield opportunities or favorable industry structures. And we want to see scalability in the problem, either because AI has a large use case it can solve, or it could be a small use case but applicable to a large number of users. So data factories. We're increasingly using this not only in that sourcing side, but also in the diligence side of things with companies we talk to, and looking at sort of trying to ensure they have an architecture set up to create a data factory for themselves. But what do we mean by that? So it does start with the collection and ingestion of data, and that data can come from sensor data, application data, document data, but it also can come from government public data. It could come from vertical data where the company is then marrying that data with proprietary data to create unique insights. But data collection and ingestion is only sort of one part of what we want to see. We'd also want to see that they basically have a pipeline or factory, if you will, in place where first they can prep the data and clean it to make sure that it's usable by AI models. That then they've got a pipeline to feed that into a continuous training process, a continuous deployment process, and then ultimately a feedback loop that takes sort of learnings from the inferences that it's providing, along with a new continuous stream of data to ultimately make that model, better and better over time and be able to do new things with it. All right, so to summarize, sort of what we've covered here over the last 20 plus minutes, we do believe we're at a current inflection point. We think there's a lot more to AI than just generative AI, although generative AI is really cool and important. We do think the world will likely move towards open source and smaller custom models, but the foundation models will still have a place. Data factories are going to increasingly become a core component of enterprise applications. Certain segments of the market are more ripe for disruption than others from generative AI. And the bottom line is it's all happening now, not 1 year, 5 years, 10 years from now. And, with that sort of as a backdrop, Babak, why don't we take some questions?
Yeah, no, let's, fascinating presentation, Rich. Thank you. There's a lot to unpack there. I guess, one of the big lines of thinking out in the marketplace is, if you're a founder, entrepreneur, is sort of, what does this all mean for my product roadmap? And the concepts of data factory, and I need to have a robust AI strategy in place. What does that actually mean for my business? That's sort of one concept. Second concept is like whether I have access to proprietary data or not, as that becomes one of the key crown jewels of all business models, has been, but increasingly so going forward. And then I think investors who are part of this conversation are focused on sort of what does this mean for how I allocate capital, how I think about deploying money. And the way I sort of, simplistically was trying to think through this is, I think for non-technology industries, there's incredible opportunities with a lot of these AI tools, both for revenue enhancement and for cost savings. So like there's a margin uplift that's going to come, but also a certain level of productivity that's going to come along and a certain level of revenue growth for those that lean in, right? It becomes a bit of a technological existential moment of like whether you're really embracing the changes that are happening or not. But let's park what it means for other sectors on the side, whether it's customer service and being able to use bots instead of having a very human intensive contact centers, or dealing with customer service that way, or sales leads, or what it does for your sales and marketing in terms of automation and generating content. Within tech, how do we think about where the value will accrue? One of the first companies and areas that has obviously come into everybody's thinking is companies like NVIDIA, like the semiconductors, which is we just need this new infrastructure of accelerated computing, and that's sort of an easy first step to build that. But how do we think about other potential areas that you feel may have, meaningful benefit as you see this play out?
Yeah, so we'll focus on Gen AI for the person to answer, because obviously, depending on what we focus on, it might differ a little. So I think you've touched sort of on the first. So there's sort of three broad areas I think that benefit. So or that achieve, that sort of take most of the benefit. So one you've touched on, which is we're going to increasingly have new workloads, additional workloads to run. So anybody that's in the game of basically providing storage and compute for these AI workloads is likely to benefit. The second area is what I would call tooling vendors, right? So in order for people to build these models, train these models, deploy these models, there's a bunch of infrastructure necessary to do that. And so I think you're going to see, a whole new set of companies arise around that. That's going to accrue a lot of value. And then the third, if we talk in the application space, it sort of touches on where we already went, right? Earlier was sort of that framework we talked about, where I don't think every industry and every sector will be equally touched on the technology side from generative AI. I think there are certain subsegments of the market, particularly those that involve that complex content generation as a big part of sort of the value they provide, or synthesis and analysis of existing content. And there are some markets combined with the data factory that are better set up to leverage that than others.
Yeah. Well, one of the areas that we have talked about internally, and you and I have talked about, is around software development. And this is, I think, a very powerful and fascinating concept, in that the number of folks today who are technical developers and can write code at sort of a sophisticated level, you're talking about maybe in the tens of millions of people. I think what the changing interface here has done, going to conversational AI, being able to use images and video, has opened that up to probably 1 to 2 billion, knowledge workers around the world who are not technical by nature, but can now sort of develop maybe the applications that they need, or the business line folks become your technical folks as well. What, in your mind, what does this do to the number of applications, number of workloads? How do you think about sort of like cloud versus the edge? I mean, this is like a pretty material shift, that 1 billion people can now put together custom apps. What does that do to, if we look out 5, 10, 15 years from now?
Gosh, there was a lot in that question. So I think what it ultimately does is it enables us to do more, right? So like, it kind of goes back to your question of like, is everybody going to lose their job at the end of this? Like, does this put us all out of work? And, I think software programmers are a great example of this, right? So like when I started coding, long ago, I can develop an application way faster today. Like there's all sorts of tooling and infrastructure and improvements that have happened to make developers more effective and efficient. And at the end of the day, the result of that was we don't have less programmers now. We have massively more programmers, right? We simply do a lot more, right? So I think, the answer to your question is, while I can't envision exactly all the things we'll be able to do, it's sort of like we have many more startups, many more technology companies building many more cool things than we did 30 years ago, with, the same number of people. And so I think the same thing will happen here, right? So as you embolden line workers and things like that, it isn't necessarily that we need less software programmers now. I think those software programmers will then move to other new and interesting things that they have, perhaps still unique skills to do that we weren't able to get to before, right? Because we were doing all the things that now the business line worker can do directly for themselves.
Yeah, I think to me, the big difference is we were sort of always giving more tools and better and faster tools to the same cohort of people, the sort of the technically enabled developer. And I think that audience, with the change to conversational AI and changing the interface of how you can get there by skipping that layer, is an exponential move. And I don't believe that this is an incremental move. I think this is like a real exponential move in number of applications that we're all going to have in front of us, the need to handle all of these from a security perspective, the need to actually monitor this increasingly complicated stack where you have the number of applications exploding higher. And I would envision that if your point of view around the models, the AI models, moving to more custom AI models and using the underlying open source technology, that you would have in parallel an equivalent, larger number of models that sit out there as well on the AI side for every entity that's sort of unique to them and their own data.
Yeah, I mean, you're already seeing this, and again, it depends on where the model debate ends up, right? But like you're already seeing companies come out that basically say they're almost going to be like your personal assistant, right? So I'm going to ingest all your email, all your voicemail, all your documents, everything, right? And be able to effectively tell you anything about sort of what it is you know or have said, and, sort of be a hyper productivity tool for yourself. And one way that could be executed is through these larger context windows with a foundation model, or it could be executed as a bunch of hyper small models. As far as the underlying execution path, I think that's still TBD. But if you would go down that custom open source route, which probably makes more sense from a latency perspective, right? Because you can run it on your desktop on the edge, back to your edge compute question, then yeah, you could end up with, billions of models, if you will, out there, right? All sort of hyper customized to my individual needs.
Yeah. We have some, there's a lot of questions coming in, but we have some questions that are revolving around your point on one of the factors that we're looking at around where big tech doesn't necessarily have a foundational advantage. And one of the things that you hit on was cost. I think there's cost, and I think the other one is around who has access to your data, right? If your proprietary data and your verticalized business becomes one of the biggest area of value that you have, then exposing that into training other people's models is probably not something that you're really going to want to do. But how do you think about sort of, does Microsoft have like a growing dominance, Microsoft and Google going forward, the pros and cons of doing that versus how the other side, like provide a little more detail in the scenario that you were talking about of how people could adopt custom models, and we can go down that road, what that might look like.
So when you're asking a question about exposing, are you talking about like using cloud, exposing it in that way, or exposing it in terms of like
as training data? Yeah, as training data. I'm if I'm a company developing therapeutics and I have a lot of in-house data over trials, over other therapeutics and compounds. If I'm a law firm, if I'm a political legislative shop that has years and years of sort of like bills and legislation and sort of the right training data to be able to produce, right? Like we have over the last 2 years, look at some of the examples out there. We have the first ever entirely designed by generative AI compound that has entered phase 1 trials. We now have something in the pipeline that is entirely end-to-end designed by that. We have a few months ago the first piece of federal legislation that was put forth that was entirely written by ChatGPT. So these aren't, it's not, I think some people have in their mind that these are sort of lower level tasks and lower level automation is sort of what we're all seeing, but the complexity of what can get done here is pretty vast. And what separates one entity from another is really like the data you have in-house, the verticalized know-how that you have. And then you have to balance compute costs, like you said, how you deploy an AI strategy against the training data that you have. But like, how would businesses think about that and think about it from an open source perspective?
Well, so the big guys like OpenAI have introduced the ability to sort of have your own sandbox, if you will, and train it. So they're trying to move into the world that says, you know, you don't have to expose your data to the rest of the world. You have to expose it to us, right? But we're going to sort of put you in your own sandbox. So it's sort of a variation of the argument you'd make about using cloud, right? Where there's some level of exposure to a third party, but you're trusting that third party, but you're not mixing that data. So that's a route companies could go. A second route is they can use an open source, build their own custom model, but they could do it in a cloud provider, right? And then the third, of course, is they could continue to be sort of an on-prem. You know, we don't want the rest of the world to have any access. You know, from a there are multiple cost components to things, right? So there's the people cost, right? Of like, do I have the talent and the people to actually do the things? The lowest lift is obviously if you use the open AIs of the world, right? And you're basically fine tuning an open AI model with your data. You know, the one that requires the most people, right, is if you're going true open source, fully custom model. There's obviously compute cost to the training itself. Like there's a lot of factors. It's not super simple, but if in some of the examples you gave, I think more and more what you're going to see is people opting the route of the custom model on open source and having at least some level of in-house talent around it. And the models themselves will get better and better to where the incremental training or fine tuning, as it's called, on your data set will require less and less of a heavy lift from a people perspective. As to whether people do on-prem or cloud, that's that debate's not, I don't think, unique to AI, right? Like that's your business is thinking about those I guess challenges and how they feel or what their point of view is. It isn't really AI specific. You'd have the same considerations, I think, AI or no AI, about are you comfortable with your data in the cloud?
Mm-hmm, mm-hmm. Do you feel, and I know this is a little bit outside of your area of expertise, but does AI going forward make us more secure or less secure as a society, as individuals? How do you sort of view that?
Yeah, so there's obviously there's a lot of different ways or vectors you go down with that. So I'll pick one in the interest of time, which is, and I'll answer, I think it makes us less secure. And the vector I'm going to pick is, if we think about we're feeding all of this data now to an AI model, and it's coming out with some form of answer for us or prediction or optimization. But because we fed all this thing into a singular engine, and the engine itself doesn't necessarily have a lot of, we'll call it access control or governance over it, we could inadvertently even forget about publishing it to somebody outside of our corporation, right? Like traditionally, when it comes to information security, even within a corporation, right? Like there's certain data certain people can see and certain people can't see. Some of those barriers, by bringing all of these disparate data sources together to draw insights and then spit them out to human beings, the models don't really have much of a governance or access control model to prevent somebody from seeing data that maybe you wouldn't have traditionally wanted them to see. So I think that's an interesting area actually for a company to be built to try and help solve those problems. But I think that's that's an example of an area where I feel like people are going to get exposed to information that maybe we don't want them exposed to. And in that sense, from a corporate level of security, I think there's some concerns there.
This again might be a little bit outside of your core area of expertise. We have a lot of questions coming in. Do you think there is a role or an increasing role for quantum computing in this new era of increased computing needs and larger, more complex models? Any quick thoughts on that?
Yeah, I'm not going to purport to be an expert on quantum computing, but I mean, conceptually, I think the answer is probably yes, right? Because the whole, in a world where we have increasing compute, and if you sort of marry that to the fact that quantum computing is intended to, sort of be a price performance, improvement when it comes to compute power, the thing again where I'm not a super expert on quantum computing is AI is more about vector multiplication and vector math, and so whether quantum computing and vector math together pair very well, sort of goes beyond my realm of expertise.
Any observations? Again, another question from the queue. Any observations from some of the emerging early type of businesses or new business models that you're seeing? That, or at least you would talk about category-wise, that are interesting with this move in generative AI?
Well, I think a popular narrative that's out there is that because of the costs of how this works, that you're going to probably increasingly need to see models that are more consumption-based versus seat-based or license-based, because inference incurs a cost. So businesses ultimately are going to have to find a way to pay for that cost. And you may decide that, there's already consumption models in certain industries, right? Like Snowflake and other places, right? I think that what might have traditionally been a SaaS-based model in a lot of places, I think may move towards a more of a consumption-based model, the more it leverages AI. So that's my first thought that comes to mind as an area or a model change that may happen.
Yeah. I know we are just past time here, Rich. And the final question that I asked, which you did not answer,
Right.
what is the impact of what is the impact of, there's early numbers. I think, Goldman put out a study, and there were some comments out of IBM, a number of other folks around, impact on employment. Let's say, initially here, I think a lot of these tools are going to be amazing productivity tools side by side with a lot of the human workers. We're short anyway on skilled labor globally, and that probably takes a number of years to resolve through that. But over the medium term, do you see sort of how do you envision this role as it pertains to number of jobs, number of headcounts? Does the automation ultimately catch up? And are you and I having this conversation just privately on our own, or are we still? Do we all still have jobs as we know them today?
Yeah, so the answer is I'm an optimist on this front. And I touched on one of the main reasons why earlier, is that yes, I do fundamentally believe that you will need less people to do the same amount of work. That AI's productivity will basically that's what will happen. But I think it's a bit of a false narrative because it assumes the world stays static, right? And that we don't grow the overall pie. And so the software developer analogy I used earlier, I think, is one sort of perfect example of that, right? Like it takes a lot less today to build a piece of software than it did back then. But we don't have less software programmers. We simply have grown the universe of what we do with software, right? And I think that analogy still holds, right? I believe fundamentally we'll simply grow the pie, we'll tackle more problems than we could, we'll have more businesses, and they'll all be more profitable, right? Because of increased productivity. I don't think increased productivity necessarily has to lead to job loss. Obviously, there will be certain job functions that are more impacted by this. Like, I don't know, say a translator, for example, might be an example of a specific job, right? That it might be a rough future path. But again, as a society, we've we've gone through transformations before. This is not the first time, right, where we've changed. Like the Industrial Revolution, right, was a massive change, right? And of course there was pain. That doesn't mean there's not going to be pain, but I guess I fundamentally have optimism about humans as a society, that while we may not know what that next set of jobs will be if certain jobs are automated out of the way, we will figure it out, and there will be a next set of jobs that gets created that don't exist today. So
Great.
I guess that's how I'd answer it.
Appreciate it, Rich. Appreciate everyone's time. This is obviously a pretty meaningful change and a pretty material move, as Rich mentioned, just in the overall technology cycle. It has a lot of implications, not just for technology, but for sectors outside of tech. We, of course, as a firm, spend every hour of every day having various discussions around different parts of enterprise tech as we're focused on that. And we have spent endless hours on this topic and looking through various thematics and businesses. We'd love to continue the conversation with those who are interested. Unfortunately, today we're wrapped up in terms of the time that we have. We really appreciate everyone's time. A recording of this session will be posted to our website. So if you'd like to share it with any colleagues or other members of your team, please feel free to go to our site and to share the link from there. I appreciate everyone's time. Have a great day.